Okay, so first thing we're going to do is discuss what is an inequality. An inequality is a mathematical sentence that compares expressions. That is what an inequality is. Solution of an inequality is a value that makes the inequality true. And then we have solution set. And that is the set of all solutions of an inequality. One of the important things to know is when we are doing solution sets, there is a specific way to write it, and that would be in set notation. So set notation. Set notation looks like there's two different kinds. So one of the ways looks like this. And so if we're using a set notation that looks like this, essentially what this means is here, the set of all C this line here means such that, and then it would read C plus 9.4 is greater than or equal to -6. Now, typically, we don't use this format for our set notation. We normally, in this class, use the set notation that looks like this. So we have a brace, and then we have this. So this reads that the brace reads the set of, so the set of, and then all of X such that, and then this part here is telling me that X is greater than 0. So if you are asked to give a formal answer in set notation, this is what set notation is and what it should be looking like. Now we're going to take a look at writing an inequality and what it means to write an inequality.
I have a question.
Yeah.
So when you're writing a set notation, what is set notation used for? To show solutions of the inequality?
Yes.
Okay.
So like I wouldn't want to list every number that's greater than 0. Right? Yeah. That's like virtually impossible. So instead, we would use a set notation in order to show all the possible solutions.
Okay, thank you.
You're welcome. Okay, so now we're going to look at writing inequalities. So here's the first example. A number C plus 9.4 is greater than or equal to -6. So exactly how you read this from left to right is how we write this from left to right. So a number C, so this is our variable. I don't know what that is. Plus 9.4. 9.4 is greater than, so this has to be greater than or equal to -6. So we just simply take the words and put them in the form of math, reading from left to right. Here's another example. 6 is greater than a number P minus 8. So again, I'm going to read it and I'm going to write it in the same order. 6 is greater than. So 6 is greater than a number P. That means that it's my variable and I don't know. Minus 8. Okay, again, very straightforward. Okay, one more example of how to write an inequality. Let's say I had 10 is no more than the sum of 3 times a number y and 4. So 10 is no more than. So I know I have to start with 10, and no more than would translate into what?
Less than or equal to.
Okay. So it could be 10, but it's not more than 10. The sum of 3 times the number y, so 3y plus 4. So there you have it. That is our writing inequalities. Again, you're just going to read and write and translate the words into math. Now we're going to look at solving an inequality. Sorry about trying to get everything so you can view it. So every time we go to solve an inequality, there are 4 things that I would like you to do. This is for every solve. Okay, number 1, solve it. That's pretty straightforward, right? Do the math, everybody. Okay, number 2, graph. And then my rule here is no floating. And what that means is your graph needs to be on the actual number line, not floating in the air, please. And then for number 3 is the first check, which this checks your math. And then number 4 is the second check, and this is the check the solution set. So number 4 is checking the answer to the inequality. So every time we solve an inequality, this is what your work needs to look like. These 4 things for every single inequality. So let's go ahead and take a look at our first example of solving an inequality. So here's my inequality. X minus 7 is greater than -5. So step number 1, solve it. So I'm going to have x minus 7 is greater than -5. I'm going to add 7 to both sides. I end up with x is greater than 2. Okay, so I solved it. Second step, graph it. Now when we graph, I expect a minimum of 2 numbers on the graph. You could do 3 if you wanted, but a minimum of 2. So I always have a 0, and then I always should have the number that's part of my solution. So this is a 2, so I have a 2. Now I need to look back at the inequality. Is this an open dot or a closed dot?
Open.
Open dot.
Open.
Has to be open because it's not equal to. And then am I shading to the right or am I shading to the left? Because x is greater than 2.
Right.
Right.
Okay. So I have now graphed. Here is step 3, checking my math. So I have x minus 7 equals -5. My x is 2, so I substitute that in. Minus 7 equals -5, and I get -5 equals -5, so that checks out. My math is correct. Then I go on to step 4, which is checking the solution set. So I have x minus 7 is greater than -5. Now I'm going to pick anything I want to represent x as long as it is part of the solution. So the solution has to be anything greater than 2. So any number greater than 2. So let's just say we're going to choose 100 because why not? So I'm going to substitute 100 in for x. Minus 7 is greater than -5. Okay, 100 minus 7 gives me 93, and 93 is greater than -5. That is correct. So I know that my solution set checks out. And that is looking at solving an inequality. So pretty straightforward. Should feel pretty similar. Let's go ahead and do another example here. We might end up having something be a little bit more complex. So let's take this example, for instance. I might have -4/9 plus 5/6 is less than or equal to z plus 4/9. Okay, who has an idea about the first thing I probably need to do here?
Convert your fractions. I mean, find the LCD.
Okay, I need to get a common denominator. And looking at this, I should know that my common denominator is going to need to be like 18. So I'm going to rewrite this using a common denominator of 18. So if you need to over here, you can say like -4/9 times 2/2 makes -8/18. Then I have 5/6 times 3/3. That made 15/18. And I have 4/9 times 2/2. And that makes -8/18. So I'm going to rewrite this inequality, and that is a -8/9 plus, I'm sorry, I don't know why I put 9. It should be 18. Okay, but -8/18 plus 15/18 is less than or equal to z plus 8/18. Okay, so the next step is that I probably need to combine like terms on this side. So when I do that, I end up with, anyone know?
7/18.
Okay, so I have 7/18 is less than or equal to z plus 8/18. Okay, and then what do I do here? I need to isolate z, so I need to create a zero pair with this. I get negative 8/18 and a negative 8/18. So z has to be what?
Negative 1/18.
One.
Okay, so this is what we're thinking. Now we need to graph, do our math check, and do the solution check. So if I'm graphing this, this is my step 1 here. Here's my step 2. I'm going to graph. I have a 0, and I have here negative 1/18. This is z is greater than or equal to, so this has to be a closed dot because of the equal to, and then I am going to be shading in what direction?
To the right.
Okay, so I shade to the right. Okay, there we have it. Then I'm going to go back and I'm going to check that my math is correct. So here I have negative 4/9 plus 5/6 is less than or equal to, then we're substituting, negative 1/18 plus 4/9.
Isn't it greater than or equal to?
Well, when I read it from the left to the right, I read it as less than.
Okay.
Because when I read going this way, this symbol is not greater than. It's less than or equal to. So from here, now I'm going to go back and I am going to double check that my common denominators were correct, right? I want to make sure of that. So when I do that, I end up with negative 8/18 plus, this is 15/18 is less than or equal to negative 1/18, and this works out to be plus 8/18. I combine over here, I end up with 7/18 is less than or equal to, and this works out to be 7/18. So I know that my math is correct. Now what I'm going to do is I'm going to go on and I'm going to double check that my solution set is correct. So in order to do that, I am going to pick a number in the solution set to solve to make sure that it's right. So here's number 4. I have, and since I've proven that my conversion of my fractions is correct, I'm going to use these fractions in order to not show that work again. Okay, so I have negative 8/18 plus 15/18 is less than or equal to. Now this is where my variable is. I can pick anything. So I'm going to pick 0 because it's in the solution set and it's going to be hecka easy to use as a check, plus 8/18. So now when I go about solving this, this ends up as 7/18, which is less than or equal to 8/18. If that statement is true, then I know my work checks out. Questions about that? Are we feeling okay? Okay, here's my last example for you all. I have here 7 is less than 2k minus 3. So just like if we were solving an equation, the first thing we're going to want to do is we are going to want to isolate our variable. In order to do that, I'm going to start by moving this constant. So I like to rewrite my problem so I know what the original problem was. So I'm going to add 3 to both sides. After I do that, I come up with 10 is less than negative 2k. Okay, what is my next step going to be?
You divide, you will divide both sides by -2.
Okay,
Divide both.
After you divide both sides, you do need to switch the sign.
why?
It's because you're dividing or multiplying.
Okay, but why?
Because
Because the number before the variable is -2. 1.
Okay.
I mean, like no constant, so 1.
Okay, but why do I flip the sign? You guys have told me because the number in front is -2 and you've told me that I need to do it, but no one's giving me a mathematical reason. You're telling me a rule, but no one's proved the rule.
I mean, you could say if you want to isolate k, you need to divide by the coefficient because you're doing the inverse operation of
Yeah.
what's happening.
So let's say that I do that inverse operation and I end up with 10 is, I'm sorry, not 10, 5, -5 is less than k. Let's say that's my answer.
Oh, is it
Now my question is this the answer? And why or why not?
No,
Okay, no. How come?
because like when you're dividing by like a negative, you need to flip the sign because you're like so you basically flip the sign.
Okay, so here's the thing though, in math, we can't just memorize a rule and do it. We have to know the reasoning why. So what I'm hearing a lot of is, I've memorized this rule, I want you to do it, but we don't know the reason why. So part of what I want you to figure out today is why, the why. Why do you need to change the sign? And it's not because that's the only way the answer is correct, okay? And it's not because I Googled it and Google told me I had to. You need to have the understanding of the mathematical reasoning behind it, please. Now, with that being said, we are going to have a couple quick classwork problems and some do nows. So here are my do nows that I would like you to solve. Yes.
Is it because like the number with the smaller absolute value, when you divide it by a negative, it would be closer to 0 than the number with the greater absolute value?
I don't know, is it?
Okay.
Okay, these are do nows. That means these are practice problems in your notes. And these three, when you have finished these three, you are going to check in with me and I will tell you what we're going to do next.